Want to cook? Well, the first thing you must do is to light your gas stove. But why does your stove sometimes burn with a blue flame and at others it appears yellow? And why do utensils sometimes turn black from the outside? Keep thinking.
Hello and welcome to another episode of Chemistry with me, Devabrata Goswami. Today's episode will be all about alkanes. Today we will talk about the physical properties of alkanes like boiling point and solubility. We will also discuss a few chemical properties like halogenation. Then we will move on to combustion and pyrolysis. And last but not the least is the exam decoded section. You must know by now that alkanes are saturated hydrocarbons. All the carbon-carbon and carbon-hydrogen bonds present in an alkane are single covalent bonds. These bonds affect the properties of alkanes. Let us see how, starting with their physical properties. As I have just told you, alkanes are compounds which have single covalent bonds between two carbon atoms or a carbon atom and a hydrogen atom. Since the difference in electronegativities of carbon and hydrogen atom is almost negligible, alkanes are almost non-polar. Hence, the only intermolecular forces which are at work in alkanes are van der Waals forces. And how do you think the van der Waals forces affect the properties of alkanes? Well, the trend for the boiling points of alkanes is that the boiling point goes on increasing with increase in the number of carbon atoms. This is because as the molecular mass and the size of the alkanes increase, the magnitude of van der Waals forces also increase. Consequently, the boiling points also increase. Now, how do the van der Waals forces affect the physical state of alkanes? The first four alkanes, that is, methane, ethane, propane and butane, are all gases. The next 13, from C5 to C17, are liquids, and the higher members with more than 18 carbon atoms are waxy liquids. Alkanes also exhibit isomerism from butane onwards. Isomerism is the phenomenon of existence of two or more compounds possessing the same molecular formula but different properties. So, let's find out what happens to the boiling point of isomeric alkanes. Among isomeric alkanes, the branched chain isomers have lower boiling points compared to their corresponding straight chain isomers. The more the branching, the lower is the boiling point. This is because branching of a chain makes the molecule more compact. A compact molecule has a lower surface area and hence the magnitude of the van der Waals forces also decreases. Let's take the example of pentane to get greater clarity on this concept. Pentane has three isomers: N-pentane, which has no branching, isopentane, which has one branch, and neopentane, which has two branches. The boiling point is the highest in the case of N-pentane and the least in the case of neopentane. Now that we have had a look at the boiling point of alkanes, let us see what affects their solubility. Alkanes, as we know by now, are non-polar in nature. So, which will be the solvents in which alkanes will be soluble? Alkanes follow the rule of like dissolves like. that is, alkanes being non-polar themselves, will be insoluble in water, which is a polar molecule. But alkanes are soluble in non-polar solvents like ether or carbon tetrachloride. Moving on, let us now look at the chemical properties of alkanes. Since alkanes are saturated hydrocarbons, they are much less reactive and are generally inert towards acids, bases, and oxidizing and reducing agents. But alkanes do undergo some reactions. Since they are saturated compounds, they can only undergo substitution reactions. Recall that substitution reactions are those reactions in which an atom, ion, or group of atoms or ions in a molecule is replaced by another atom, ion, or group. Now, substitution reaction for an alkane takes place by the replacement of a hydrogen atom by a halogen, nitro group, or sulfonic acid group. When one or more hydrogen atoms of an alkane are replaced by a corresponding number of halogens, then it is a halogenation reaction. And that is exactly what we are going to study now. Halogenation of alkanes takes place either at high temperature or in the presence of diffuse sunlight or ultraviolet light. To understand this more, let us look at the halogenation of methane. Methane is made to react with chlorine in presence of diffused sunlight, ultraviolet light, or at a high temperature of 573 to 773 Kelvin. Each hydrogen atom in methane is replaced one by one. Firstly, chloromethane is obtained, then dichloromethane is obtained, then trichloromethane, which is also known as chloroform, is obtained. And finally, when all four atoms of methane are replaced, we get carbon tetrachloride. During the reaction, a mixture of different halogenated products is formed and the various halogen derivatives have to be separated from the mixture. Halogenation of alkanes yields many useful products. Chloroform is employed as a solvent and is also used in the production of freon refrigerant R22. Tetrachloromethane or carbon tetrachloride also finds its use. Where? Keep thinking. For more such interesting quizzes and puzzles, log on to our website www.topperlearning.com. But while you are thinking about the question I asked you, I will take a short break. Stay tuned because after the break, we will continue talking about properties of alkanes. Welcome back. I am Devvrato and you are watching Chemistry 11. Today we are talking about properties of alkanes. Before the break, I had asked you a question. My question was, what is carbon tetrachloride used as? Carbon tetrachloride is used as a solvent in synthetic chemistry research. It is also used in pharmaceutical industries. I think that has raised some questions in your mind. Here is a caller with a question. Go ahead.
I am Rachel. Sir, I would like to know if all halogens are equally reactive towards alkanes.
That's an interesting question. Let me tell you that all halogens are not equally reactive towards alkanes. The reactivity of halogens towards alkanes is maximum in the case of fluorine and minimum in the case of iodine. So, fluorination is a highly violent reaction, so violent that it is impossible to control it. And bromination occurs in a similar way as chlorination, but the rate of reaction is much slower. Iodination of alkanes, on the other hand, is a very slow and reversible reaction. Iodination, therefore, is usually carried out in the presence of some oxidizing agents like iodic acid. Iodic acid helps in the conversion of hydrogen iodide to iodine. Iodine moves from oxidation state of -1 to 0 and is hence oxidized. The concentration of iodine increases and the reaction proceeds in the forward direction. Another important property of alkanes is combustion. When alkanes burn in air, they combine with the oxygen present in the air and are completely oxidized to give carbon dioxide and water with the evolution of large amounts of heat. This is known as combustion. The heat which is released during the process of combustion is called the heat of combustion and is denoted by delta Hc naught. Alkanes give out a large amount of heat during combustion, and this property of alkanes enables their use as fuels. Alkanes like methane, ethane, propane and butane are highly combustible and are used as fuels. Let me take you back in time now. How far, you will ask? Well, only as far back as the start of the episode. I had talked about the flame of gas which we use at home, which burns with a blue or a yellow flame. Well, let me tell you, the LPG that is used in our homes is a mixture of propane and butane, which are highly combustible. All alkanes burn with a blue flame on complete combustion. When the combustion of alkanes is incomplete, that is, sufficient amount of air or oxygen is not available, carbon black is formed. And it is due to this incomplete combustion that the flame is yellow and smoky. This carbon black, when deposited over a period of time, leads to the blackening of utensils. But carbon black is not only an unfortunate side product of combustion, it is also useful. Do you know that this carbon black can be used in the manufacture of ink and black pigments? Now, I will introduce you to a new term called pyrolysis. If you look at the word pyrolysis, pyro means heat and lysis means breaking down. Hence, alkanes undergo pyrolysis when a higher alkane is decomposed to smaller fragments by applying heat. Pyrolysis is also known as cracking and is one of the most favorite terms of petrochemical engineers. After all, it is this process which gets them the products they need. Pyrolysis has an application in the preparation of oil gas or petrol gas from kerosene oil or petrol. Dodecane, for instance, is an integral constituent of kerosene oil. When dodecane is heated to 973 Kelvin in the presence of platinum, palladium or nickel, a mixture of heptane, pentene and other products is obtained. This was about the chemical reactions of alkanes. Let us study the structure of alkanes now. We know that alkanes contain carbon-carbon single bonds or sigma bonds. Therefore, atoms involved in the single bonds can rotate freely about the axis of the carbon-carbon bond. This rotation results in different spatial arrangements of atoms in space which can change into one another. Such spatial arrangements of atoms which can be converted into one another by rotation around a carbon-carbon single bond are called conformations or conformers or rotamers or conformational isomers. For example, for ethane, infinite number of conformations are possible. How? By keeping one carbon atom stationary and rotating the other carbon atom around the carbon-carbon axis. There are two extreme cases possible. One of the conformations possible is in which the hydrogen atoms of both the carbons are as far apart as possible. This conformation is called staggered conformation. The other is in which hydrogen atoms of both the carbon atoms are as close together as possible. Such a conformation is called eclipsed conformation. All the other intermediate conformations are called skew conformations. Conformations can be represented by two projections, sawhorse and Newman. In sawhorse projection, we view the molecule along the molecular axis. The central carbon-carbon bond is drawn as a longer straight line. The upper end of the line is slightly tilted towards the right. The front carbon is shown at the lower end of the line, whereas the rear carbon is shown at the upper end. Each carbon has three lines corresponding to the three hydrogen atoms. These lines are inclined at an angle of 120 degrees to each other. The next projection is Newman projection. In this projection, the molecule is projected at the carbon-carbon bond head-on. The carbon atom nearer to the eye is represented by a point. The three hydrogen atoms attached to the front carbon atom are shown by three lines drawn at an angle of 120 degrees to each other. The rear carbon is represented by a circle, and three hydrogen atoms are shown attached to it by the shorter lines drawn at an angle of 120 degrees to each other. Out of all the conformations, the staggered form is the most stable. This is because in the staggered conformation, the electron cloud of carbon-hydrogen bonds are as far apart as possible. Therefore, the force of repulsion is minimum between hydrogen atoms in the case of staggered form. Well, that's enough for today. But before I take you through the tips and tricks that will help you score in your exams, let's take a short break. Stay tuned, because coming up next is Exam Decoded. Hello, nice to see you again. You are with me, Debobroto, and today's episode is all about alkanes. Let's see what all we have learned today. Alkanes are non-polar molecules with weak van der Waals forces existing between them. The boiling point of alkanes increase with the increase in the number of carbon atoms. Alkanes are insoluble in water but soluble in non-polar solvents like ether or carbon tetrachloride. Alkanes undergo complete combustion in the presence of air and form carbon dioxide and water. Pyrolysis is the process in which higher alkanes break down into smaller fragments by the application of heat. The different spatial arrangements of atoms in a molecule, which can be obtained due to rotation about the carbon-carbon single bond, are called conformations. For ethane, infinite conformations are possible. Out of all these conformations, staggered form is the most stable. It is time for Exam Decoded now. So without further ado, let's get straight to it. Welcome to Exam Decoded. I will begin by testing your knowledge of alkanes. Yes, it's time for the rapid fire round. The rules are simple. I will ask you 5 questions. You will get 5 seconds to answer each question. If you get it right, 1 mark is yours. So, let's start. First question. The intermolecular forces present in alkanes are A. Van der Waals forces, B. Hydrogen bonding, C. Ionic forces, D. Dipole-dipole interactions. And the answer is option A. They are Van der Waals forces. On to the next question. Alkanes are insoluble in A. Water, B. Ether, C. Carbon tetrachloride, D. Benzene. Answer is A. Water, as alkanes are organic compounds. They will be insoluble in polar solvents. Water is the only polar solvent in the given list. Moving on to the third question. Large amount of heat is evolved during combustion. True or false? Of course it is true. Fourth question. Decomposition of higher alkanes into smaller fragments by applying heat is A. Pyrolysis, B. Addition, C. Substitution, D. Isomerism. The answer is A. Pyrolysis. Pyrolysis means decomposition by heating. And your last chance to score. Boiling point of alkanes decreases with branching. True or false? The correct answer is true. After that round of quick fire questioning, it is the moment of truth. If you got all questions right, then congratulations, because you are our topper high flyer for the day. A score of 3 to 4 makes you an achiever, and anything less means you are still a learner. And in case you want to go from a learner to being a high flyer, take my advice and visit www.topperlearning.com. It is your one stop for all things related to exams. This episode is all about the properties of alkanes and falls under the unit of hydrocarbons. The unit has a weightage of 8 marks and is critical from the examination point of view. Typically, short answer questions worth 2 to 3 marks are asked, and they will usually test your knowledge ability. Here is a sample question that will give you an idea of what to expect from the examiner. What are the products formed on chlorination of methane? This type of a question is typically worth 3 marks. If you want to get that perfect score in the exam, you must know how to write the ideal answer as well. And I will show you how to do just that. Write this statement correctly and 1 mark is yours for the taking. When chlorine reacts with methane, hydrogen atoms get replaced by chlorine atoms one by one. Write each reaction correctly and you will get half a mark for each. All of this, if written correctly, will add 3 marks to your kitty. Well, I hope that helped in clarifying your concepts. If you need more help or you have any doubts, do visit topperlearning.com. Well, it's time for me to say goodbye. But before I go, I would like to ask you something. You would have all heard of crude oil and its price shooting up all the time. But has the composition of crude oil ever crossed your mind? Crude oil contains a large mixture of alkanes of varying chain lengths, from the small methane molecules to molecules with more than 50 carbon atoms. These compounds are separated by distillation and converted into desired products by cracking. Remember the soft corner petrochemical engineers have for cracking. And you can crack your exams by logging on to www.topperlearning.com. Until next time, keep thinking. This is Debabrata wishing you a stress-free preparation.